I'll do my best, but this is pretty much as good as it gets. If I do a complete croak that you can't understand, just let me know. I'll try to do better with it. Okay, so we basically left off with needing to talk about business applications. So with business applications, we'll want to kind of have some definitions first. So our first definition is revenue. And revenue is money received and if we sell X items. So obviously, you don't just have money coming in for nothing, right? I mean, unless you're like a nonprofit and you get donations or something, right? That's different. But, so a company is only going to get money, receive money, if you sell X amount of items, okay? And we'll talk about it, you know, an overall company, technically, right, has more than one product and so on, but that gets complicated. So we'll just kind of consider as if there's just one product that we're looking at and considering at a time, okay? So then there's also the price that it's kind of sold at, right? Because, well, you sell X items at a specific price. Now, I'm going to be very specific here that price is a lowercase p, okay? Because we'll talk about profit, and profit is an uppercase P, okay? I'll try to remember to always put it in function notation when it's profit, but I will promise that I'll always remember to. And my throat is going to continually be dry here. So, if we want to talk about a specific type of kind of price equation, more or less, to help us figure out the revenue, it is called the demand equation. And the demand equation is literally the amount sold, okay, so that's X times how much we sold them for, right? Okay, so, so price and quantity give us demand. So, once we have kind of that information, we can then take it into revenue. And then, because this is kind of telling us what we have, what's being sold. So, if you know the demand, you can multiply it by, what do we think? Any ideas? No ideas? So, if we want to think about revenue, what is revenue, right? We've pretty much already said what it is. It's how much money you're bringing in based on a specific product. So if, let's do it on candy because it's Halloween. So if we sell Smarties for 50 cents, I know, but I could have said $1 for one. 50 cents a piece, right? So the revenue that we bring in is how many Smarties we sold at 50 cents, right? So as for our example there, the Smartie revenue would have been 50 cents times how many we sold. So we'll call that S, right, for Smarties, just for now. But what is that? What did we say this really is? Generally, what variable would we give it in this example? It's just X, because it's X items. It's the quantity. So revenue, or R of X, to keep it in function notation so that I try to remember to do that later, is literally just X times price, right? Because that's what the 50 cents was. The price, remember, sometimes we're told it, sometimes we would need to write an equation for it, okay? I know in methods, a lot of times you have to write out the kind of demand equation or the price equation, okay? And then we just multiply it times X, and that's how you get revenue. Make sense? Okay. So, from here, we have the next thing is profit.
Oh, I'm sorry.
Mm-hmm.
All right, so the demand equation is price plus quantity?
It's not plus, it's just price and quantity. It's some combination. Generally what you'll have is like this. It's 50 cents per one of them. And then you get another point kind of thing. Then you would sell 6 of them for $3, right? So then you would have to take those 2 points and write a line. And that would be your price or demand equation. Okay? As long as you remember to keep P, the price, as the Y. Okay? I will almost continually forget that because it really does seem like the price should depend the amount kind of thing should be the independent variable, right? Because it doesn't matter so much. The price does though. So, I don't know. It's backwards though. Okay? Is that, no? So it's not multiplication. You would get 2 points and you'd have to write it.
Okay.
Just like any line. Yeah.
Oh, so,
This is an and, this is just comma. These are two things that make up the demand equation. Okay? Does that help, not having the and sign?
in other words, it's X and Y, right?
Just quantities that you need, items that you need to know. Okay. But we don't really have to do this too much. It's just within this topic, you have to do this in methods. So if you take business methods instead of life science methods. Okay? So let's get back to profit then. What is profit? Right? We said what revenue is. It's the money brought in by selling items. So what's the profit?
Wouldn't profit be the amount of money you have left over after all expenses are paid?
Yes. It's all the money left over after you pay your expenses. So we call expenses in this model cost. So profit is what you keep from the revenue after you take away the cost. So we would write that as P of X is equal to R of X minus C of X. If this is profit and this is revenue and this is cost. Okay? Does that make sense? So revenue is just what you bring in, not what you keep, right? Just all the money brought in. Because let's go back to the Smartie model, right? We sold Smarties for 50 cents a piece. But what about making them or buying them, right? How much did we buy them for? Okay, so then however much we got from selling them for 50 cents a piece, we would need to subtract out the cost of buying them. And then maybe the labor of the person that was selling them, or I don't know, if they're kept in a warehouse.
You okay?
Miss dry throat. I need to like actually sleep for once this week, so yeah. So we'll see how today goes with speaking, because it's just getting worse. All right. So from here, let's just quickly define cost, since then we'll have all of our different kind of pieces. So, like we said, cost is literally just your expenses, right? So a lot of times that's going to be product cost, okay, in these models, but like I said, sometimes it could be labor or, you know, just basic costs, okay? And then you also have things that maybe the cost changes. So, like, if we have a warehouse, well, we have to pay rent on the warehouse no matter what, even if we don't sell anything. But if we sell things, then we have to buy more of them to keep selling, right? So then that portion of the cost changes based on how much we sell. So you have to kind of think about it in that way. Does that make sense? Okay. So let's now do an example. So we have the price, P, and the number of t-shirts sold X satisfy the demand equation P equals negative 0.14x plus 14. Okay, so remember, this is not profit, this is price, because it's a lowercase p. Okay, it's the demand equation, which is also the price equation. So, first part of the question is, what is the revenue? So, R of X, basically. So what is the revenue equation? How do we get that? What do we do?
Price and quantity?
Would one be first, get rid of
I'm sorry?
Would we want to get rid of cost first?
We get rid of what?
I'm sorry, I'm thinking.
Okay.
That's probably because I'm, well, whatever, I'm isolating my head.
No, we don't need to.
I'm isolating my head.
So what do we have? We have the price equation, right? And we know that, right, P is the price, X is the item sold. So how do we get revenue? The definition's over there. We multiply by X. Just price times quantity, right? Because X is the amount sold, that's the quantity sold, times the price. The price isn't just a value, because the price is dependent on how many we sell, right? Okay, so all we do for R of X is we take X times P, which is X times negative 0.14x plus 14. So then we can simplify. So R of X is negative 0.14x squared plus 14x. Right? So then the second part is what quantity of t-shirts maximizes the revenue? So, how do we figure out what the maximum is? Well, first, does the revenue equation have a maximum? Because what type of function is this?
It's a revenue.
It's a parabola. Facing in which direction? Up or down?
Down.
Down. So it has a maximum, right? Which is what value? The vertex. So, how do we find the vertex? X is equal to negative b over 2a. And what quantity of t-shirts maximizes revenue? This is the value that we want, right? Not what is the maximum revenue, just how many t-shirts do we have to sell to maximize the revenue, right? Okay, so what are these values? What's the top?
14.
0.14 because the negatives cancel over,
Wait, that's.
oh, soup, yep, negative 14, just kidding. I pulled A instead of B. Over 2 times negative 0.14. Yep. So then, if we put that in the calculator, because we all know we will, just make sure that you put parentheses around that entire denominator, or, right, figure out, calculate the denominator, then do the division. So do it in 2 pieces. Okay, because otherwise the calculator will just think it's negative 14 divided by 2 times negative 0.14. And it will be completely different. Okay? So the answer there should be 50 t-shirts. Okay? So we have to sell 50 t-shirts to maximize the revenue. So that means if we sell 51, we'll make slightly less. Isn't that an odd concept? I mean, it kind of makes sense, right? Because then, well, our cost has gone up. Maybe there was a break for only buying 50 or something, which I have no idea how that model makes any sense, but go with it, right? Okay. So then, next is we do actually want to find the maximum revenue. So how do we do that? We know how many t-shirts we have to sell to get the maximum revenue, but how do we find the actual maximum revenue?
Plug it in.
Plug it in to what?
The original.
The R of X equation, right? So R of 50 is equal to negative 0.14 50 squared plus 14 times 50, right? So then if we multiply this out, remember to square the 50 first, then multiply by the negative 0.14. We would get negative 350 plus 700. So our final answer here would be 350. So that means the most we could make would be $350 off these t-shirts. I mean, not breaking the bank or anything, but it's a nice little chunk of change. I'd take it. Okay, so then it keeps going. There's like I parts to this question. What price should be charged to, for the maximum revenue. So, basically, what we've figured out so far is we have to sell 50 of them to maximize the revenue. $350 is the maximum revenue, but now we wanna know how much do we have to sell the t-shirts for to, right, sell 50 and get $350 out of it. So how do we do that?
So, on the left side, we'll put 350, since we know we have to, yes.
Well, let's figure out what we're putting it in, what we're doing, kind of thing first, right? What this is asking?
Yeah.
So we wanna know what price we have to charge.
You want to get the maximum?
To, yes, to get the maximum amount.
50.
I'm sorry?
So would you plug in 50 to get the maximum?
Where?
To the original?
Well, we just did that to get 350.
Question.
So we're not asking what is the maximum revenue. We're asking how much do we have to charge per t-shirt to get that maximum revenue.
Would you just divide, I'm sorry.
I mean, that's a good thought, right? And it would work because technically, right? Revenue is quantity times price. So if we divided 350 by 50, we would get it. But I want to make a different connection, so we're not going to do it that way. But it's good that you see it. What were we given at the very beginning of the problem?
No price.
A price equation. We just got to plug it into there. That's it. It's a price equation. We just want to know what price we have to charge per t-shirt.
Also, the 50 is going to be plugged into that one.
Yes.
Okay.
Or you divide it into the max revenue. But you don't always have to find the maximum revenue, so it's good to know multiple ways of doing things. So we're going to do P equals negative 0.14 times 50 plus 14, which is negative 7 plus 14, which is 7. So that means to maximize your revenue, remember this is revenue, not profit. So to maximize your revenue, we sell t-shirts for $7, which is dirt cheap. Then we have to sell 50 of them, and we'll make $350. Okay? Does this make sense kind of now? You see kind of how they've interacted? Okay. What did he do with this thing? It's like, it disappears. It gets hidden every class. Okay, so then part E is, so say the cost of producing X t-shirts is given by C of X is equal to 2.8X plus 100. Express profit as a function of X. So basically what it means by express profit as a function of X is just find P of X. Alright? So, how do we find P of X? Profit.
Revenue minus cost.
Revenue minus cost. So, P of X is equal to R of X minus C of X, which is our revenue equation that we found, negative 0.14x squared plus 14 minus cost equation, which we just got told, 2.8x plus 100. Now, I wrote those parentheses on purpose because we're subtracting a quantity, right? So, we need to do what now? Is this marker like not visible very well now? It's pretty much dead, yeah, okay, cool. So, we will distribute and combine like terms. So we have P of X is equal to negative 0.14x squared plus 14. That side didn't change, right, because it didn't have a negative on it. It's just being subtracted from. So then minus 2.8x minus.
Wouldn't that be plus? Okay. No.
Just distribute the negative, yeah. Mm-hmm. And then minus 100. So then combine like terms, which there's really only the 14 and the 100. So our profit equation is negative 0.14x squared minus 2.8x. And then what is that? Negative 86. So that is our profit equation. So now, we're on F, right? What quantity of t-shirts maximizes profit? So, what type of equation is this? Parabola, facing which way? Down, so it has a maximum. All thoughts that you should have. You maybe don't have to go through the steps each time, but the thoughts are important to at least kind of be there subconsciously that it is a downward facing parabola. So that means we can find a maximum, because not all the time. They might ask you for maximum and then there is no maximum or something, right? Yeah, it would be no solution in that case. Mm-hmm.
Why did you drop the x off of the 14? Because in this equation here, you have negative 0.14x squared plus 14x.
Because I didn't see it, because my black marker was dying.
So does that change?
It does.
Okay.
Yep. Good catch.
Thank you. Except I wrote this whole thing.
Sorry. Sorry for those of you using pen. Joke's on you. Happy Halloween. Okay, so 14 minus 2.8 is 11.2 minus 100. Good catch though, because that's going to throw us way off. Okay, so now we want to find how many t-shirts do we have to sell to maximize the profit. Vertex, yep, it's a little repetitive, right? But we're doing it with a different equation and we will be surprised. So the x is equal to negative b over 2a, which is negative 11.2 over 2 times negative 0.14, which again, if you put that all at once, just make sure you have those parentheses, and we get 40 this time. So depending on what you're trying to maximize, it changes how many you should sell. Because before we were maximizing the revenue, right? And so maybe, you know, some companies are based on revenue, right? And then, I don't know, their employees get, you know, bonuses or something if they have a certain revenue point that they meet. But the company itself cares more about the profit, right? Because that's the money that they're actually keeping. So while maybe, you know, an employee would want to get to the 50 t-shirts because they would meet their revenue point quicker, the company really only wants them to sell 40 because that's going to maximize their revenue, or sorry, their profit. So they'll actually get more money from selling 40 versus selling 50. Okay, they keep more money. All right. So then we have G. It's the problem that just keeps giving.
Six.
Yeah, there's not that many. And they don't all have I parts kind of thing either, right? No. Then there'd be like 2. Okay, so what is the max profit? So we know what quantity maximizes the profit. Now we just want to know what is the maximum profit. So what do? Plug it into what? Profit equation, right? So we want P of 40. So that will be equals negative 0.14 times 40 squared plus 11.2 times 40 minus 100. Okay, so if we put that in our calculator, we would get, we want the piece, what each term equals if we put it in? Okay. We would get negative 224 plus 448 minus 100, which then goes together to be $124. So before, we sold 50, we brought in 350 bucks. But now, we sold 40, we get to keep $124, right? Just because we brought it in does not mean we get to keep it. Okay. Now, we want to know what price we have to sell the t-shirts at to maximize the profit. So H. So, yeah. Yes, we keep. That's the money that we made, we keep it, we've already paid our expenses. It's like basically you have a paycheck, right? But you don't get to keep all of it. For one, well, you have to live somewhere. You probably have to buy gas. You have to feed yourself, right? All of those would be your costs. Your paycheck is your revenue. What you have after you pay all those things is your profit, if you have any left, which is the sad state of things sometimes, right? So, now we want to find the price. How do we do that? Price equation, which I just erased. But it was P equals negative 0.14x plus 14. We just plug 40 into that, right? So P is equal to negative 0.14 times 40 plus 14. So then the price is equal to negative 5.6 plus 14. So we end up charging $8.40 per t-shirt. It's very specific. Not 7, but $8.40. But I've also found if you're selling them like yourself kind of thing without like credit card option, right? You sell things for a weird price like that, you end up getting the $9 or the $10 and they just say keep it because they don't want to deal with the change. I sold Girl Scout cookies, so I know this for a fact. I got a lot of just extra. Okay, so far we've done all the things to bring in the most money. Now we've done all the things to keep the most money. Now, yes, let's do something with spending money, the cost. How'd you know?
You see what happens?
Yep. You make, you keep, you spend. So, part I, what is the cost function if the cost to produce t-shirts is $4.20 each. So, if we're literally being told here, we want to find out the cost to just produce the t-shirts, right? Producing a t-shirt costs $4.20. How do you think we write this equation?
We told that it's for the price, well, no, what is the price on the
$4.20.
price? I forgot which one, but which equation that is,
The profit. P of X,
Mhm.
profit.
So we wouldn't give it?
We don't have to plug it in.
420.
You gotta multiply by.
We just multiply it. Because if we want to know the cost of producing something, right, we have to know, well, how many are we needing to make and how much does it cost per, right? So like back to the Smartie example. If it costs us 10 cents to buy each thing of Smarties, right? Then per Smartie that we sell, well, we had to buy it first for 10 cents. So 10 cents times quantity, or X, right? So in this case, C of X is equal to 420X, or 4.2X. You don't need the 0. It's just because it's, units is dollars, so we go by 2 decimal places. Okay? So, this is different from the other cost equation that we were given in the problem because that was cost overall, right? This is just like cost to produce this one item, okay? So maybe that included building expenses and so on, right? Okay, so we have revenue, cost, profit, price, demand, all sorts of things, right? Okay, so if they're both lines. Generally, right, sometimes we'll get cost to be another parabola. Obviously, you don't want to maximize cost, right? Because, well, you don't want to spend more than you have to. You would want to minimize it, which makes sense because it's also going to be positive, so it will have a minimum, right? So that's another feature that they could ask, is literally just the opposite of what we were doing before with profit and revenue, where we were finding maximums and then what is the maximum, what price, gives us the maximum, and so on and so forth, right? We could find the minimum cost. All of these values will be different if, you know, we were to find one where we had to sell the same amount for multiple of them, that'd be like the peak, you know, good number. Okay, because then that would mean we're maximizing, like, say, profit, and, yeah, where's this going? And minimizing the cost, all at once, which is like best case scenario. Okay, so in the last few minutes here, we'll just kind of start in on section 4.3, which is polynomials. So, let me go erase those blank. So, this is polynomials, and recall that, so if we have different functions, f of x is equal to 3x to the 7 plus the square root of 5 times x squared plus 6. G of x is equal to 8x to the 6th minus 5x to the 10th plus 2 all over 7, and h of x is equal to x cubed minus 4x over x squared plus 1, and j of x, running out of letters here, is equal to the square root of x plus 5. So recall which one of these, or ones of these, are polynomials. What's f? Polynomial. Why? What about the square root of 5? Does that matter?
No. The x isn't under, it's not under.
The x isn't under, so we don't care.
This is 4.3.
Yes, polynomials. So, because it's just the number, we don't care. It's just, if x was under, then we would care. What about g? Polynomial. But what about the 7?
There's no x to it.
There's no x, just a number again. What about h? Rational, not a polynomial, because of the x's. What about j? Root, we call it technically, but it could be a radical too. It's pretty much the same word, more or less, because the x is under. Yeah. So only f and g quantify as polynomials, right? So now we have some definitions. So the degree of a polynomial is the highest power of x that appears. Okay, and then we have some more. The leading coefficient is the coefficient of the highest degree term. And one more. The constant term is the term without a variable. So let's look back at f. for our example. I need to erase one. If we're looking at f, what would be the degree of the polynomial? 7, because, well, the other terms are to the second or to nothing, to 0, right? Because there's no x. So then what is the coefficient, the leading coefficient? 3, because that's the coefficient of the degree 7 term, right? Then what's the constant? 6, because it's the term without a variable, right? So highest degree and leading coefficient and constant term. Okay? Then let's do G. What is the degree of the polynomial? 10. Doesn't have to be in the first term, right? So that's the highest degree. What's the leading coefficient then? It's a trick question. Don't forget about the dividing 7, right? So the leading coefficient is -5/7. Because essentially what you want to do in this case, separate that 7 out so that you make each term just be a fraction on its own instead of an overall fraction. It'll help you see that better. Does that make sense? And then what about the constant term?
2 sevens.
2 7s. And obviously we can't do those because they're not polynomials. Okay. Let's see here. How are we doing? We're pretty much done. So, it doesn't have to be the first term that's the highest with the leading coefficient, okay? Usually we'll put them in that order, but sometimes we won't always because, right, like if it's negative, sometimes it's so easy to lose that negative then. So that's kind of why we don't always put it first. I don't always write it first then, because I've dropped many a negative that way. Okay? All right. Don't party too hard. Happy Halloween. Have a good weekend.